Hi everybody, we are still in problem set 1.1. And we are now in question 20. And question 20 and all the questions between 20 and 25 talk about the figure in the previous page, figure 1.5b, which is this figure in the bottom of page 9. Okay, this. So let's copy it so we can see it. We have the 3 axes. Okay, we have the x-axis and the y-axis and the z-axis, and also we have 3 vectors. We have the vector u. Okay, so let's say it's this one here. I make it 12 centimeters. And we have another, this is in blue. Let's make the other one v in red. So let's make it 10 centimeters. And another one, let's make it in green. Say 9 centimeters. And we call it W. Okay, the lengths are not important. We just want to make some length so we can divide it later easily. Okay, so we have U, V, and W. And in my painting, they are U, the blue one, V, the red one, and W, the green one. Okay, let's go to the question. So the question starts with how much is a third of U plus a third of V plus a third of W. And then they ask us how much is half of U plus half of W. So let's start with half of U plus half of W because it's easier to explain. So half of U plus half of W, okay, half of U plus half of the blue one plus half of W, half of the green one, gives us the point in the middle, okay, between U and W. Why? Because if we connect U, if we add U plus W, we would reach, I'm showing you, if we go along U, we walk, we get to here. This is U, to here. And then we walk and we want to add W, so we add this green line to the where we finished with U. So we walk along W, so we reach here, okay? But we want half of this distance. So it's in here, in the middle, okay? We explained all this in question 15. It's exactly the same. Here, there, it was with different letters. The vectors had different names, but it's the same principle. Okay, we have the point in the middle. If we make a line between this point and this point, it's right in the middle. Let's make this point. Okay, and I'm trying to draw it so it looks reasonable about here. So this is the middle between U and W. And now they ask us how much, oh, okay, and why. Do you understand also the logic? We explained it when we talked about question 15. Okay, when this line pulls in this direction and this line pulls in this direction, and they have equal length, so none of them is stronger, so it's right in the middle. Okay, so in the same way, if we had half u and half v, okay, it would be, I know it's not the question, I'm getting there, so it would be in the middle here, half u plus half v, half of the blue plus half of the red would be 3.5 plus quarter, would be about here. This is half u plus half v, and half w plus half v, I know it's not what they asked, and I have a reason why I'm doing this. 1 second. I want to show you something. So half w plus half v, half of the red one plus half of the green one in my picture, it would be half of 10.5 centimeters, let's say 5.25. Okay, here. So this is the middle of this line, this is the middle of this line, and this is the middle of this line. The name of so each one, okay, if we have this triangle, the black triangle that is drawn in dashed line, this triangle, we have 3 medians, okay? We have the point that connects this part of the triangle with the middle of the line in the opposite part, okay? So we have, if we connect it, they all meet in a certain point, okay? Between the vertex and the segment that is opposite. Okay, I'm talking about things from geometry. We didn't learn them in the book, but in geometry you learn that all the 3 medians, each one is called a median, a line from, we are talking about this triangle, a line from a vertex of the triangle, okay, some sharp tip, to the opposite line segment and the middle of the opposite line segment. This is called a median. This is also a median, and this is also a median. And they all meet in the same point, here. Okay, so this is the point where all the medians meet. And this is the point where what they ask us, this is where they ask us. If they ask us in the question about third of u plus, okay, note that this is not half, this is third. Okay, it's also like this was an average and we got to the middle of this, not the middle of the angle. Okay, we don't care about the angle, it's the middle of the line between them. So this is also the middle of the distances, like a weighted average of all of the 3 vectors. So this is a third of u plus a third of w, plus a third of v, just to make it according to the order of the letters in English, u and then v and then w, plus a third of w and what it gives us is this point, okay, the meeting of the three medians. Okay, if we take this vector from the origin to this point, this is the answer that they asked. Okay, they asked how much is a third of u plus a third of v plus a third of w. So this is it. Okay, let's make it in, I made it in orange, but you can't see, but I'll retrace it in yellow. Here, now you can see it more clearly. It's this vector, and if you want one point, it's this point. Let's call it, so this equals to, for example, just to give it a name, what letter do we give it? What comes before U? C, D, F, G, H, I, J, K, L, M, N, P, Q, R, S, T, U, V, W. Okay, so it's T. Okay, let's call it, this is the letter that comes before W and V and U. And I don't want to use X, Y, and Z because these are the axes, X, Y, and Z. So let's call it T. So this equals to T. Okay, and T, I'm just showing you that this is the, T is the yellow thing. Okay, this point, or this vector if you want. I'll show you that this is a vector by making an arrow. Okay? And T, sorry that I didn't draw it in orange, I should have written it in orange. T is a vector. Okay, so a third of u plus a third of v plus a third of w is T. And okay, what do, again, because each of them has the same strength, no one is stronger than the other one, so each of them pulls to his side, and they meet in the middle. Where is the middle? The middle is the point where these medians meet. Okay. This is also, by the way, in geometry, that you learn that this is the center of gravity of the triangle from the same reason. Each one is pulling how much material it has, and they meet in the middle. Okay, no one is stronger than the others. They are all the same. Okay, and okay, now we answered about this one and about this one. Now we talk about a challenge problem. One second, let's see the challenge problem. Under what restrictions on C, D, and E will the combinations C times U plus D times V plus E times W, okay, something times the blue vector plus something times the red vector plus something times the green vector, fill in the dashed triangle. The dashed triangle is what we drawn here. I'm sorry. This is the dashed triangle. Okay, so we want to fill it up. So in the same way that we had in question 16, okay, in the previous question 1-6, okay, 16, we had in question 16 we talked about what happens if CV plus DW, okay, in question 16, we talked about C times V plus D, this is a vector, okay, and V, and D times W. The V and the W are vectors, the C is just a number, and the D is just another number, okay, these are scalars, or just simple numbers. The V and the W are vectors. So we talked about what happens when C plus D equaled 1. And we talked about it that it gives, if like this was C and this was D, and we had this line between them, C plus D equals 1 described all this line between the vectors. So in the same, if you want, you can look in the video of question 16. So in the same way, if we talk about, we want to have this, and this is in one dimension, okay? This is a shape in one dimension, it's just a line, okay? Because we have two vectors and between them they make a line. If you want to, if you want the same in three, with three vectors that create a two-dimensional shape, okay, a triangle, the dashed line triangle, so it's the same. We just take the condition would be C plus D plus E equals 1. Okay, the numbers that multiply, if we have C times some, I'm sorry, yes, C and D and E. If we have C, let's write it in a new page. I'm making a more sloppy drawing now because you understand the principle. If we have, these are the axes, this is x, y, and z, and we have the blue vector, which is u, we have the red vector, which was, don't remember exactly, I think I got it wrong. This was, sorry. Again, we'll make the axis, x and y and z, and we have, this time I will check, u and v. And w, and they ask us what is the triangle that connects these 3 points. I'm just drawing this in with the ruler so it doesn't come out terrible. So this triangle, it's the same as we had this line between the vectors. Before we had C and D, and they C times, let's say, some number times this vector plus some numbers D times this vector, and if we had C plus D equals 1, it was this dashed line. This was two vectors and they gave a line, so it was one dimension, one line, just a line with one dimension. If we have three vectors, they create a shape in two dimensions, which is a triangle, okay? But it's the same. We should have C plus D plus E equals 1, okay? it's just the same. C, some number, times the blue vector, plus D, some other number, times the red vector, plus E, some yet another number, times the green vector. If we keep this condition, C plus D plus E equals 1, this equals to the surface or the area of, maybe it's confusing to say surface, let's say area, the area of the dashed triangle. Okay? Here, all this area if we keep C plus D plus E equals 1, this is the area of the dashed triangle. Okay? So, and of course, like they said, it should be that C equals or greater is bigger than 0, or like, so it's not exactly 0, because if you understand that if we have if we need a triangle, we can't have one of the arrows, like if all the arrows are 0, we don't have a triangle. It's completely degenerated. It's like collapsed on itself here. Okay, so they say C is greater or equal to 0, D is greater or equal to 0, and E is greater or equal to 0. So it's like they accept also this condition, like maybe that it's okay that it's degenerated to a 0 area, but they don't want it to have a negative dimensions. Okay, like it can't have a negative area, so the arrows can't go back. So this is one condition, and the other condition, it's like the book says. So this is one condition, one, and the other one is like the book says, that C is greater or equal to 0, comma, D is greater or equal to 0, comma, E, sorry, is greater or equal to 0. And I think that's it. These are the two conditions. Okay, so this was question 20. So thank you and goodbye.